folks, Rational Raphael here, talking to you about adding and subtracting rational expressions. Now here's a question. What do you call a turtle who takes up photography? A snapping turtle! Cowabunga!
First thing we're going to talk about is a rational expression. That would be a fraction whose numerator and denominator are polynomials. So down here you can see 4 examples of rational expressions. They're just fractions whose numerators and denominators are polynomials. Here we have a numerator that is a quadratic trinomial. Quadratic because it's degree 2, trinomial because it's 3 terms. Here our denominator is a linear binomial. Linear because it's degree 1, binomial because it's 2 terms. Here our numerator is a quadratic monomial. Here our denominator is a quadratic binomial. Here our numerator is a 4th degree binomial. Here our denominator is a cubic monomial. Here our numerator is a cubic trinomial, whereas here our denominator is a quadratic trinomial. Now let's talk about excluded values. Those would be any values that, when plugged in, cause the denominator to equal 0. So all we're looking for are values of the variable in each of these rational expressions that would cause the denominator to equal 0. So in order to figure out these excluded values, all you have to do is just set your denominator equal to 0 and solve for your given variables. Now let's quickly review adding and subtracting fractions. So to add or subtract fractions, make sure that the fractions have a common denominator. This often requires that you multiply it by a form of 1. Then you can add or subtract the numerators and leave the common denominator the same. So when we add or subtract fractions that do not have a common denominator, we need to make it so that they do have a common denominator. So we often have to multiply them by a form of 1, meaning the same thing in the numerator and denominator. So in this case, when we're adding together 2/7 and 1/2, we need to make sure that the denominator is the same. And the least common denominator between 7 and 2 is going to be 14. So we multiply this first fraction by 2/2 in order to get our denominator to be 14. We multiply the second fraction by 7/7 in order to get our denominator to be 14. We then add the numerators together, keep the denominator the same. Works the same down here. When adding 3/4 and 2/5, what's the least common denominator between 4 and 5? That would be 20. So we're going to multiply our first fraction by 5/5. That would be a form of 1. That gets our denominator to be 20. Then we're going to multiply our second fraction by 4/4. That's a form of 1 and gets our denominator to be 20. We then subtract our numerators, because we're subtracting in this case, and leave our common denominator the same. Sometimes after you add or subtract, you will be required to simplify also. Be aware of that. Now let's talk about adding and subtracting rational expressions. So to add or subtract rational expressions, here we have 2 rational expressions that we're trying to subtract. The first thing we're going to do is completely factor the numerator and denominator of each fraction. So here, our numerator, factored. Our denominator, not factored. It is a quadratic trinomial. How do we factor a quadratic trinomial? By using the magic x. So we're going to take our a value times our c value, put that in the top of the magic x. So 1 times 15, that goes in the top. Our b value, which is 8, that's going to go in the bottom. We then think about 2 numbers that multiply together to make positive 15 and add together to make positive 8. That would be positive 5 and positive 3. We then divide each of those numbers by our a value, which is 1 in this case, and simplify if possible. These are as simplified as we get, so we're going to then factor this using the bottoms up method. We create 2 sets of parentheses. In the first set of parentheses, the number at the bottom goes with your variable. We're going to go 1x plus 5. In the second set of parentheses, it's going to be 1x plus 3. Now we have completely factored this denominator. Up here, 4, that's already factored, and then a plus 5, that's already factored. So we have completely factored the numerator and denominator in each fraction. So we can move to step 2, which is to state any excluded values. These would be all a values that would cause our denominator to equal 0. So again, we set our denominators equal to 0 and solve for a. When we set this denominator equal to 0, we're going to use the 0 product property and set each of these factors equal to 0. So when we have a plus 5 equals 0, we solve that for a, we get a is equal to -5. When we have a plus 3 is equal to 0 and solve for a, we get a is equal to -3. So those would be 2 excluded values. Over here, we set a plus 5 equal to 0, solve for a, we get a is equal to -5 again. So we only have 2 excluded values. A cannot equal -5 and a cannot equal -3. Either of these a values would cause one of our fractions to equal 0 and therefore be undefined. Next, step 3, we want to make sure each fraction has a common denominator. So like we were just saying, if you want to add or subtract fractions, they need to have a common denominator. This denominator is a plus 5 times a plus 3. This denominator is a plus 5. they are not the same denominator. Well, how do we get them to be the same denominator? Well, since this denominator has an a plus 5 and this one does as well, the only difference is this a plus 3. So I'm going to take the quantity a plus 3 and multiply it to this denominator, and that would give me the same denominator as over here. But whatever you do to the denominator, you have to do to the numerator. It's a form of 1. That way it doesn't actually change the fraction. So now, how does this simplify? Well, over here, this fraction is going to stay the same. It's still going to be minus. And now, in this fraction, the 4, I'm going to distribute to the a and to the 3. So it's going to be 4a plus 12 in my numerator. In my denominator, do not FOIL it out. Just leave it completely factored like it is over here. It's going to be a plus 5 times a plus 3. The reason is because at the end, we're going to hope that something cancels out. Once we have simplified our numerator, add or subtract the numerators together. So these two numerators, we're going to subtract them. Now, this is the step that everyone messes up. See how it's minus this numerator? You don't just subtract the 4a. You have to subtract the 4a and the 12, meaning you're going to have to distribute the negative to the 4a and to the 12. So in our numerator, once we combine these two fractions, it's going to be a minus 4a minus 12. Please note that the denominator stays the same, just like it normally does when we add or subtract fractions. Now what we need to do is actually subtract the a and the 4a, and we end up getting negative 3a. Now, when adding or subtracting rational expressions, by the end of your question, you need to completely factor the numerator and denominator. And that's because there's a chance that something in the numerator will cancel out with something in the denominator. So what I'm going to do is factor this numerator right here. How do I factor it? Well, there's actually a negative 3 that I can factor out from each of these terms. So I'm going to take negative 3, put it on the outside of a set of parentheses. On the inside of the parentheses, I just divide each of these terms by negative 3, and I end up getting a plus 4. Now, nothing cancels in this case, but that's okay. Sometimes it will, sometimes it won't. Now, at the end of your answer, please always make sure to state your excluded values.
What does the turtle do when he hears music? Slow dance! Example time.
Now, example 1 says simplify each expression, state any excluded values. So here we have two rational expressions that we are subtracting. Now, the first step is to completely factor the numerator and denominator in each of these fractions. Done. Second step is to state any excluded values. So what values of m and n would cause the denominators in each of these fractions to equal 0? Well, the good thing is that the denominators are the same in each of these. So I could just take one of the denominators, set it equal to 0, and figure out what value of m and what value of n would cause the denominator to equal 0. And it's just 0 for both variables. So I say m cannot equal 0, n cannot equal 0. Now I move on to step 3, which is to make sure I have a common denominator in each of these fractions. I do, so I can move on to step 4, which is to add or subtract my numerators and put it all over our common denominator. So 7 minus 3 is going to give me 4. I put that all over our common denominator, and it seems like we're done. But you need to make sure that this can't simplify any further. And it actually can simplify further because we have a 4 in our numerator and this 2 in our denominator. These can simplify. 4 over 2 simplifies to 2 over 1. So we end up getting 2 in our numerator and just mn to the third in our denominator. Now note, at the end, I didn't write m cannot equal 0, n cannot equal 0 because I wrote it right here. These are my excluded values. Part B, doing the same thing. So step 1, we need to make sure our numerator and denominator in each fraction is completely factored. It is. So we move on to step 2, which is to state any excluded values. So what values of x would cause either of these denominators to equal 0? So I could set this denominator equals 0, solve for x, I get x cannot equal 0. Over here, do the same thing. I set this denominator equal to 0, solve for x, I get x cannot equal 0. So that would be my excluded value here. Now I move on to step 3, which is to make sure that each fraction has a common denominator. So these are not common denominators like they were up here. So how do I make sure that these have a common denominator? I figure out what's the least common denominator between 6x and 2x squared. Well, this one has 2 x's, this one only has 1. So I clearly need to multiply this fraction by x over x. Now this denominator has a coefficient of 2, whereas this one has a coefficient of 6. So I need to multiply this fraction by 3 over 3. So that's how I'm going to get them to have a common denominator. This fraction I multiply by x over x. This fraction I multiply by 3 over 3. That gives me the least common denominator of 6x squared. Now I multiply. 1 times x gives me x. 6x times x gives me 6x squared. Then I add that to 3 times 3 gives me 9 over 2x squared times 3 gives me 6x squared. Now we have a common denominator. So we can move on to step 4, which is to add or subtract our numerators and put it all over the common denominator. So here we're going to add x squared and 9, put that in our numerator and put that all over our common denominator, which is 6x squared. And because there's nothing to factor out of each of these terms in our numerator, there's nothing we can cancel out with our denominator, so this is our answer. And remember, we already wrote our excluded value here. Just make sure you box it at the beginning. That way it's included as part of your answer.
Where can you find turtles on their back? Wherever you left them. You try.
Okay, doing the same thing. Step 1, we need to completely factor the numerator and denominator of each fraction. Done. Step 2, we need to state any excluded values. So what values of x or y would cause these denominators to equal 0? Well, if we set each of the denominators equal to 0 and solve for x or y respectively, we end up getting that x cannot equal 0 and y cannot equal 0. Those two values would cause these denominators to equal 0. Next, we need to make sure that each fraction has a common denominator. They do. So now we can just add or subtract the numerators. In this case, we're adding, so we're going to add 7 and 11, put that all over our common denominator, which is 6xy to the second. Now, can we simplify this at all? Yes, 18 and 6 can simplify. 6 goes into 18 3 times, so we end up getting a 3 in our numerator, and the 6 cancels out in our denominator. So we can write our answer as 3 over xy squared. Again, make sure at the beginning you box your excluded values. That way it's included as part of your answer. Part B, doing the same thing. So step 1, make sure the numerator and denominator in each of your fractions is completely factored. Done. Step 2, we need to state any excluded values. So we set each of these denominators equal to 0 and solve for a, b, and c respectively. We end up getting that a cannot equal 0, b cannot equal 0, and c cannot equal 0 because each of those would cause either one of these fractions to have 0 in the denominator and be undefined. Now we can move on to step 3, which is to make each of these fractions have a common denominator. So what's the least common denominator between a times b and b squared times c? Well, this denominator has 2 b's and a c. So for this denominator to have 2 b's and a c, we're going to have to multiply it by b times c. And this denominator has an a. This one doesn't have an a. So we have to multiply this denominator by a. And remember, whatever you do to the denominator, you have to do to the numerator. You have to multiply by a form of 1. That way you don't change the fraction. So when we multiply over here, 2 times b times c is going to give you 2bc. In our denominator, a times b times c is going to give you ab squared times c. Then we're going to subtract, and we're going to distribute this a to the a and to the negative b. So it's going to be a squared minus a times b. Now that we have a common denominator, I can move on to step 4, which is to subtract our numerators and put that all over our common denominator. So how do I subtract these numerators? Well, remember, this is the most commonly made mistake. You have to distribute this negative to the a squared and to the negative ab. So you can write your answer as 2bc minus a squared plus ab. And we're going to put that all over our common denominator, ab squared times c. Now you look and see, is there anything I can factor out from the numerator? Nope, there's nothing that each of these 3 terms have in common, so there's nothing we can factor out and cancel with our denominator. So we're going to leave this as our answer. Again, make sure you box your excluded values. Example 2, we're doing the same thing. So step 1, we need to make sure that our numerator and denominator in each of these fractions are completely factored. They are. So we move to step 2, state any excluded values. So what values of c would cause these denominators to equal 0? Well, they're the same, so we could just take one of them, set it equal to 0, and solve for c. And when we do, we get c is equal to 4, meaning when c is equal to 4, that would cause our denominator to equal 0 and therefore make these fractions undefined. So c cannot equal 4. That's our excluded value. So we move to step 3. We need to make sure that each of these fractions has a common denominator. They do. So we can move to step 4, which is to subtract our numerators here and put that all over our common denominator. So 4 minus c, we're going to write that in our numerator and put that all over our common denominator. Now, you may think that you're done here, but you have to check, is there any way we could factor out something from the numerator and then cancel something with the denominator? Well, yeah, I can actually factor out from the numerator a -1. If I factor out a -1 from the numerator, that makes this term negative and this term positive, meaning I could write it as -1 and then parentheses c minus 4. Now, why was I able to rewrite this as c minus 4 instead of -4 plus c? Because that's just the commutative property of addition. I just switched the 2 terms. Now you see that in the numerator, we have a c minus 4, and in our denominator, we have a c minus 4, and those cancel each other out, leaving us just with -1 as our answer. Remember to box c cannot equal 4 as your excluded value. Part B, doing the same thing. So step 1, we need to make sure that the numerator and denominator in each fraction is completely factored. It is, so we move to step 2, state any excluded values. So we need to set our denominators equal to 0 and solve for h. So if I set this denominator equal to 0, solve for h, I get h is equal to 5. Meaning when h is equal to 5, that would cause this to equal 0 and be undefined. So h cannot equal 5. Over here, I set this denominator equal to 0, I get h is equal to 0. So when h equals 0, that would cause this denominator equal to 0. So those are going to be our 2 excluded values, 5 and 0. Now I can move on to step 3, which is to make sure that each of these fractions has a common denominator. So how do I get these to have a common denominator? What's the least common denominator between h minus 5 and h? Well, what I'm going to do is I'm going to multiply this fraction by h minus 5 over h minus 5, this denominator. And then I'm going to multiply this fraction by h over h, this denominator. That ensures that each of these fractions will have a common denominator. So let's go ahead and do that. Over here, multiplying 4h times h, we get 4h squared. And in our denominator, we're just going to leave that factored out as h times the quantity h minus 5. The reason is because at the end, we're going to hope that something cancels out. Then we're going to write plus, and over here, we have 2 times the quantity h minus 5. So we're going to distribute the 2 to the h and to the negative 5. So we get 2h minus 10 in our numerator, and in our denominator, we leave it factored out because at the end, we hope that something's going to cancel out. Now, because we have a common denominator here, we can move on to step 4 where we add our numerators together and put it all over our common denominator. So we're going to add 4h squared plus 2h minus 10, put that in our numerator, and put that all over our common denominator. Now, is there a way we can factor our numerator? Well, we can factor out a 2 from each term, and we end up getting something that looks like this. Now, we think, is there a way we can factor 2h squared plus h minus 5 using a magic x? No, there's no neat way to factor that. So we just leave it like this. There's nothing else that can cancel out. And as always, make sure at the beginning you boxed your excluded values.
Why was the turtle so shy? He wouldn't come out of his shell. You try.
Okay, doing the same thing. So step 1, we need to make sure that the numerators and denominators in each of these fractions is completely factored. So the numerators are, but the denominators here can be factored, right? Each of these terms has a 2 that we can factor out. So I'm going to factor out a 2 from each of these terms, making it 2 on the outside of a set of parentheses, and on the inside, we just divide each term by 2. We get q plus 3. So now our numerators and denominators are completely factored, so we can move on to step 2, which is to state any excluded values. So what we're going to do is we're going to set each denominator equal to 0 and solve for q. And we end up getting that q cannot equal negative 3. That would be the value of q that would cause each denominator to equal 0. Now we can move on to step 3, which is to make sure that each of these fractions has a common denominator. They have the exact same denominator, so we can move on to step 4, where we add our numerators together and put that all over our common denominator. Now we have q plus 3 over 2 times the quantity, q plus 3. Now we look, is there any way we can simplify this rational expression? Yeah, we can actually cancel out the q plus 3 in the numerator with the q plus 3 in the denominator. Now when that happens, there's nothing left in the numerator. When that happens, you're going to write a 1 up there. In our denominator, there's only going to be a 2 left, so our final answer is going to be 1/2. And as always, remember to box your excluded value. Part B, doing the same thing. So step 1, we need to make sure that our numerators and denominators are completely factored in each rational expression. They are. So we move on to step 2, state any excluded values. So we're going to set our denominators equal to 0 and solve for k. So in this case, when I set this denominator equal to 0 and solve for k, I get k cannot equal negative 4. Over here, it's just a 3. There is no variable. So the only excluded value in this problem would be k cannot equal negative 4. Now I can move on to step 3, which is to make sure that each of these fractions has a common denominator. So what is the least common denominator between 3 and k plus 4? Well, as we said before, if we want to make sure that they have a common denominator, we can just multiply this fraction by 3 over 3 and this fraction by k plus 4 over k plus 4. That ensures that each of the denominators are going to be the same. So when I do that over here in our numerator, k times 3 is going to be 3k. In our denominator, I'm going to leave it as 3 times the quantity k plus 4. Remember, do not distribute in our denominator or FOIL in our denominator. We need to check at the end to see if something will cancel out. Then I'm going to write plus, and then up here, I have k plus 5 times k plus 4. Now, we said we can't distribute or FOIL in our denominator, but we can in our numerator. So we need to FOIL this up here. So I'm going to multiply k times k, I get k squared. I'm going to multiply k times 4, I get 4k. I'm going to multiply 5 times k, I get 5k. I'm going to multiply 5 times 4, I get 20. Now that I've multiplied all that out, I see that each of these fractions now have a common denominator, so I can move on to step 4, where I add our numerators together. And when I add our numerators and simplify, I end up getting k squared plus 12k plus 20 all over 3 times the quantity k plus 4. Now we look up here and we think, is there a way that we can factor this so that something possibly cancels out with our denominator? Yeah, this is a quadratic trinomial, so we can try to use a magic x. Again, we multiply a times c, 1 times 20, put that on the top of our magic x. We take our b value 12, put that on the bottom. We think about two numbers that multiply together to make 20 and add together to make 12. That would be 2 and 10. Now we divide that by our a value, which is 1, and we factor going bottoms up. We write 2 sets of parentheses. Our bottom number is going to go with our variable. So it's going to be 1k plus 2 in the first set of parentheses. In the second set of parentheses, it's going to be 1k plus 10. Now, nothing cancels out, but that's okay. We can still just leave this as our answer, and we're done. Remember to make sure you box your excluded values at the beginning. Example 3, doing the same thing. We want to add these two rational expressions together. So we follow our steps. Step 1, we want to completely factor the numerator and denominator of each fraction. Done. Step 2, we want to state any excluded values. So what values of z would cause the denominator to equal 0? If you're not sure, just set the denominators equal to 0, solve for z. Over here we get z is equal to negative 2. Over here we get z is equal to 7. Therefore, z cannot equal negative 2 or 7 because those values of z would cause the denominators to equal 0. Next, we need to make sure that each fraction has a common denominator. So these do not have a common denominator. How do we get them to have a common denominator? Well, when it's like this, we just multiply this fraction by z minus 7 over z minus 7. We multiply this fraction by z plus 2 over z plus 2. The reason is because this is a form of 1, so it doesn't actually change our fractions, but it does make them have a common denominator, z plus 2, the quantity, times z minus 7. So now, in my numerator over here, I'm going to distribute this 9 to the z and to the negative 7, and I end up getting 9z minus 63 in my numerator. In my denominator, I'm going to leave it factored out because at the end, I hope that something cancels out. Then I'm going to write the plus. After that, I distribute this 8 to the z and to the 2, and I end up getting 8z plus 16 all over z plus 2 times z minus 7. Now, these have a common denominator, so I can move on to step 4, which is to add or subtract the numerators and put that all over our common denominator. So let's add these two numerators together. 9z plus 8z is going to give me 17z, and then negative 63 plus 16 is going to give me negative 47. Now, there's no way to factor that numerator anymore, so nothing's going to cancel out. We can just leave our answer like this. Again, make sure you boxed your excluded values at the beginning. Part B, doing the same thing. So step 1, we need to completely factor our numerators and denominators. Here we are completely factored in the numerators. Our denominators, this denominator can be factored. It's a quadratic trinomial. How do we factor a quadratic trinomial? We use the magic x. We take our a value, which in this case is 1, multiply it by our c value, which in this case is negative 48. We put that up here. Take our b value, negative 2, put that in the bottom of our magic x. We then think about two numbers that multiply together to make negative 48, add together to make negative 2. That's going to be positive 6 and negative 8. We then divide that by our a value, which we said was 1. And when we write this factored, we are going to create two sets of parentheses, and we're going to go bottoms up. In the first set of parentheses, it's going to be 1p plus 6. In the second set of parentheses, it's going to be 1p minus 8. Now, this denominator is already totally factored, so we have completely factored our numerators and denominators. We can move on to step 2, which is to state any excluded values. Again, those are just values of p in this case that would cause either denominator to equal 0. Over here, how do I figure out what our excluded values are? I take this denominator, set it equal to 0, and solve for p. Since I have two things being multiplied together that equal 0, I'm going to use the zero product property, set each of them equal to 0 separately, and solve for p. So I get p is equal to negative 6, and p is equal to positive 8. Therefore, our two excluded values over here would be p cannot equal negative 6, and p cannot equal 8, because both of those values would cause this denominator to equal 0. What about over here? I set this equal to 0, solve for p. I get p cannot equal negative 6, just like over here. So we don't have to write it twice. We can just write it once. P cannot equal negative 6, and p cannot equal 8. Now that we know our excluded values, we can move on to step 3, which is to make sure that these two fractions have a common denominator. So the denominator of this fraction is p plus 6 times p minus 8. This fraction over here has a denominator that's just p plus 6. So we clearly need to multiply it by p minus 8. Whatever we do to the denominator, we got to do to the numerator. So we're going to multiply this fraction by p minus 8 over p minus 8. That way it's a form of 1. It doesn't actually change our fraction, but it will give us a common denominator. So this fraction over here already simplified, but this fraction we said we're going to multiply by p minus 8 over p minus 8. So we distribute that 3 to the p and to the negative 8, and we end up getting 3p minus 24 in our numerator over here. Now that these fractions have a common denominator, we can move on to step 4, where we subtract the numerators and put that all over our common denominator. Now, this is the most commonly made mistake in this question. Because it's subtraction, you need to distribute that negative to the 3p and to the negative 24 when we put that all over our common denominator. So it's going to be 7p minus 3p plus 24 all over our common denominator. We then subtract 7p minus 3p is going to give me 4p. Now, just like up here, we need to check, can this factor at all? Well, yeah, each of these terms here has a constant of 4 that I can factor out. So I take a 4, put it on the outside of a set of parentheses. On the inside of the parentheses, I divide each of these terms by 4, and I end up getting p plus 6. Now look, the numerator and denominator both have a p plus 6 as a factor that can cancel out, just leaving me with 4 in my numerator and p minus 8 in my denominator. That's as simplified as we're going to get. And remember to make sure that you boxed your excluded values at the beginning.
Teenage Mutant Ninja Turtles, Teenage Mutant Ninja Turtles. You try.
Okay, doing the same thing. Step 1, we need to make sure that the numerator and denominator of both fractions are completely factored. So our numerator here, that's as factored as that gets. Our denominator, that's a quadratic trinomial. So how do we factor a quadratic trinomial? We use a magic x. We take our a value, which is 3, multiply it by our c value, which is negative 2, put that in the top of our magic x. We take our b value, which is negative 1, put that in the bottom. We think about two numbers that multiply together to make negative 6, add together to make negative 1. That would be negative 3 and positive 2. We then divide each of those by our a value, which is 3 in this case, and we simplify these if possible. Over here, we can simplify this. Negative 3 over 3 simplifies to negative 1, but we're not going to write negative 1. We're going to leave it as a fraction so we can use the bottoms up method to factor. So we're going to write this as negative 1 over 1. Now, this is going to factor into two sets of parentheses. In the first set of parentheses, we go bottoms up. It's going to be 1r minus 1. In the second set of parentheses, we go bottoms up. It's going to be 3r plus 2. Now we can write minus, and over here, we need to do the same thing. Our numerator is factored. Our denominator, though, is a quadratic trinomial that we can factor using a magic x. And look, it's the exact same quadratic trinomial. So it's going to factor the exact same way that this one did over here. Now that we have completely factored our numerator and denominator, we can move on to step 2, where we state any excluded values. So what values of r would cause these denominators to equal 0? Well, since they're the same, we can just take one of the denominators, set it equal to 0, and solve for r. Since we have two things being multiplied together that equals 0, we have to use the zero product property. We're going to set r minus 1 equal to 0 and set 3r plus 2 equal to 0. Solve each of those separately, and it'll tell us what our two excluded values are. So r cannot equal 1 or negative 2/3. Those are our two excluded values. Now that we know that, we can move on to step 3, which is to make sure that each fraction has a common denominator. They do. So we can move on to step 4, which is to subtract our numerators and put that all over our common denominator. So because we're subtracting, remember, do not make the most commonly made mistake, which is to not distribute this negative. We need to distribute it to the 4r and to the 3. So when we put this all over r minus 1 times 3r plus 2, our numerator is going to be 7r plus 5 minus 4r minus 3. Now we simplify. 7r minus 4r is going to give us 3r, and then 5 minus 3 is going to give us 2. Now, is there any way we can simplify this further? Yes, there's a 3r plus 2 in the numerator and denominator. That cancels out. Now, what happens when everything cancels out in the numerator? We're going to write a 1. So our final simplified form of this is going to be 1 over whatever's left in the denominator, which is r minus 1. Remember to box your excluded values at the beginning. Part B, doing the same thing. Step 1, we need to completely factor the numerator and denominator of each fraction. Done. Step 2, we need to state any excluded values. So we're going to set our denominators equal to 0 and solve for t. So over here, when we solve that for t, we end up getting t cannot equal negative 4. Over here, when we solve that for t, we get t cannot equal negative 1. Those are our two excluded values. Those values of t would cause our denominators to equal 0. Next, we move on to step 3, which is to make sure that each fraction has a common denominator. Well, these are clearly not a common denominator. So how do we make them common? Well, we're going to multiply this fraction by t plus 1 over t plus 1. And we're going to multiply this fraction by t plus 4 over t plus 4. That way, the denominators are going to be the same. Now, in our denominator, we're going to leave that factored out. But in our numerator, we're going to distribute the 8 to the t and to the 1. And we end up getting 8t plus 8. We're going to write minus and then distribute that t to the t and to the 4. So we end up getting t squared plus 4t. Now that each fraction has a common denominator, we can move on to step 4, which is to subtract our numerators and put that all over our common denominator. Remember, when you're subtracting, you need to distribute that negative to the t squared and to the 4t. And we end up getting something that looks like this. Now we just simplify our numerator. 8t minus 4t becomes 4t. And is there any other way we could simplify this? Well, this is a quadratic trinomial in our numerator, but it doesn't factor with the magic x. Therefore, nothing will cancel out with our denominator, so we can just leave our answer like this. Again, make sure that your excluded values were boxed at the beginning of the problem.